Good morning, everyone. This is now target 1D. We are going to be solving equations that have rational exponents. So when I think of the word solving, it's actually one of the most important math words that you'll see. It's a skill, is what we're looking at here. So when it comes to solving for an equation for a variable like x, x is a variable, your goal is to get that variable equal to a number. So when you think about seeing the phrase solve this equation and the variable in it is x, your answer should be something like x is equal to 4. So we want to start solving things that involve rational exponents. Let's just kind of like build our way up there and look at some examples here. So let's say I want to solve for x. So again, remember our goal is to get x equal to a thing. And we have 2 to the power x is equal to 2 to the power 3. So what I want to find is some x, some number that I could plug in and substitute here that will equal this exact thing. So one thing to look at is that both of these have the same base, right? The same base of 2. And actually, I could take this over to Desmos, right? And I could do 2 to the power 3. I can't do 2 to the power x. It'll just give me a graph and won't tell me anything. But I do 2 to the power 3, it's equal 8. So what I want to know is 2 to what power is going to equal 8? Don't think too hard on it. It should be pretty straightforward. That this x has to be 3. So we actually get into a nice little rule here. It's that if we have the same bases and they're equal to one another for a power, then the two exponents have to be equal to each other. So when I see 2 to the power x equals 2 to the power 3, I know then that x is equal to 3. And again, look, we get an answer in the style of what they should be, right? X equal to a number. So let's look at another one. Again, here we have 4x equals 4 to the power 10. So I see base of 4, base of 4. So the bases are the same of these two powers and they're equal. So I know that their exponents also have to be equal. So what I'm going to do is I'm going to write an equation, x is equal to 10. And that is our answer. So here's that rule written out. If you have two powers that are equal and they have the same base, their exponents must also be equal. Okay, so that's like the level 1 problem, right? And we're just that's pretty much just bases are the same. Okay, exponents are the same. The next level, like the level 2 of it, what if their bases are not equal? So here I have 3 to the power x equals 81. So this isn't 3 anymore. Normally I would expect this to be 3x equals 3 to some power. But maybe I could rewrite 81 as 3 to some power. So let's think of our powers of 3. We have 3 to the power 1. That's 3. What about 3 to the power 2? Let's start looking. I'm again going to flip over to Desmos. Do 3 to the power 2. Okay, that's equal to 9. Which is an 81, but we're getting there. 3 to the power 3. That's 27. Again, we are getting there. It's not 81, but we're getting close. Let's try 3 to the power 4. Okay, that's 81. So 81 is disguised as 3 to the power 4. So instead of writing it like this, I'm going to write it as 3 to the power x is equal to 3 to the power 4. Now I can just use that rule that we just had, right? If two powers are equal, which again, power, equal, and they have the same base of 3, then I could just write their exponents equal to one another. So 3 to the power x equals 3 to the power 4. So then I know x must be equal to 4. The more advanced, the less you have to do stuff like this. So here we have 5 to the power x is equal to 125. Well, 125, let's see, 5 to the power 1 is 5. 5 to the power 2 is 25. And 5 to the power 3 is 125. So 5 to the power x is equal to 5 to the power 3, because 125 is equal to 5 to the power 3. So then I know x is equal to 3.